Okay, so you all don't have this problem. It's from a past exam. And you can read through here that we have a truss below supported by a pin at E and a roller at F. Determine the force in members AB, BF, and FG using method of sections, and member CD right here, using method of joints, indicate tension and compression. And so, if we're looking at this, we can, like we talked about in class the other day, if you have a cantilevered truss, that you don't even have to find the reactions, okay? And if I'm noticing what I want, it's AB, okay, and BF and FG. So if I cut right through here, if I look over here at the left, I would have one force, but I'd also have to find my reaction at the roller and my reaction at the pin, because I'd have to include all of this. If I look at this side, okay, I do have a lot of applied forces, but I don't have to find any reactions, so it saves me a lot of time. So in a problem like this, I'm just going to do the truss portion. So I want to determine the force using method of sections, and then I need to use method of joints over here at D. So when I look at joint D, remember I cut everything off except what I see with joint D. So let's start with method of sections, and I'm going to just go ahead and take a colored pen here. And, you know, again, if you guys need to do this, just don't use red on the test. Okay? And I'm looking at the pieces. I mean, these are, we don't really care about. And then I'm going to say, okay, this goes to F, goes to F, goes to A. Okay? So now when I come back to recreate by method of sections, I'm going to have, okay, B to C. And I'm going to come down here, B to G. And I'm going to come back up to that point. So I have 8 kips. I have 15 kips. I have 17 kips. I have 13 kips. And then I have, I'm going to show it in tension. Okay. And I'm going to show this one down here in tension. And then this one's up here, and it's pulling down, just like that, okay? So now when I look at my measurements, I have 6 feet, 6 feet, 6 feet. And if I want to look at this height, the whole thing is 7.5. We're going to go like this. And if it's 7.5, and I have a node here and a node here, then I know it's got to be 2.5 to 2.5 to 2.5. So if I'm looking at this node, we come down 2.5. If I'm looking at this node, I'm coming down another 2.5, and then I'm coming down 2.5 here. Okay? So I have my distances. I have that it's 7.5 from top to bottom. And I need to find, this is parallel to the ground, but I need to find the slopes of both of these. So this is where I'm going to go back with a colored pencil if I need to. And let's look at, so it doesn't matter where I start, this whole slope, you can see this big giant triangle, similar triangles, here's that same slope. So when I want to find the slope of this, I can pull this little triangle out, doink, doink, doink. And I get 6, and I get 2.5. Okay, so it is 6 is the base, 2.5 is the height. So that's down here. And we have 6 and 2.5. Okay, so that means we have the square root of 36 under 2.5 squared plus the square root of, okay, so the 6, the square root is 6.5. So I'm going to go ahead and put all of that on my picture because it just makes it easier. Okay. Now I need to look at this triangle. Okay. What am I going to do with this triangle? Well, again, I can see here's a nice little right triangle right here. It goes over, down, and we come back up. Okay. So if I take this one out, over, down, come back up, I'm still walking over 6, but now I'm walking down the entire 7.5. Okay, so that means my hypotenuse is 36, 36 center, 7.5 squared plus square rooted, and I get 9.6. So I can come over here to this, and I know that I am 7.5 up. I'm going over 6, and I have 9.6 is my hypotenuse. So I now have everything. And this is where, you know, when you're working through these videos, before I do any of this, you all should try to draw it yourself, and then go over to your little thing and press pause and make sure you can draw it, and then press play. And if you don't have the same picture, then figure out where you made the mistake. Okay, so I have everything, everything on here matches this picture. This has an X component, and both of these have XY. So summing forces in the X direction is going to leave me 3 unknown X's. Summing forces in the Y direction is going to leave me 2 unknowns. That's not helpful. If I sum my moments about point F, okay, so this is force GF, this is force BF, and this is force BA. If I sum the moments about F, I know that we have to be 0, we're in equilibrium. So I'm going to put my finger on F, and as I look at this triangle, if I am BA and I'm pulling in this direction, it's going to cause clockwise rotation. So I have BA, and its distance from here to here, from here to here, okay, from here to, it's 7.5 feet. Okay, I have this 13. These are all going to cause rotation. See, 1, 2, 3, they're all going to cause rotation negatively. So I have minus 13 times 6, minus 17 times 12, and then minus 15 times 18. And then I have 8 kips. So if I have my clock handle, I'm holding it where I'm taking the moment, and I push this direction, spinning positively. So I have plus 8 times 7.5, and all of this, all of my moments that I'm summing right now have to equal 0. Okay, they have to equal 0. And I'm not going to do all the math for you, but we're going to find that AB equals 65.6 kips, and I got a positive value. Positive means tension. So again, with a truss, magnitude, units, tension or compression. Okay, I'm going to come back up here and erase BA, and I'm going to go ahead and put in 65.6 kips. So now I have to decide, now where am I going to take my moments about? If I take my moment about point B, it gets rid of BF, and I can solve for GF. I could sum my moments about point D. If I summed them about point D, GF goes away, and I can look at directly the Y component of BF. Okay, the Y component, remember it's a vector, so we can break it into X and Y, and I can calculate BF that way. And if I sum it about D, it also gets rid of 2 of these forces. So beauty is I'm getting rid of an unknown, plus I'm getting rid of 2 forces. You can sum the moments anywhere on here that you want. I could sum them, where else could I sum them? That's about it. Okay, here or here. So I'm going to sum the moments about D. And this is where you should stop the video, and you should make sure that you can set up the equations correctly. So if we sum the moments about D, I'm going to put my thumb on D, okay? GF is going straight through, so it would cause translation, not rotation, okay? 65.6 goes straight through. These 2 forces at D are not there, so I'm left with the 17, the 13, and I'm left with this member BF. And when I look at BF, I have to remember that I can break BF up into X and Y components wherever I want to have them. So I'm choosing to break, I could break them up here, but then I'd have to figure out distances. I can break them up down here. Okay. I'm going to break it up right there at the top because it's anywhere on that vector I can break it up. And if I break it up here at the top, it gets rid of, it gets rid of one more thing I have to write in my equation. So we're coming back here, my thumb, okay. When I look at my thumb, 8 and 15, translation, not rotation, they're right there. But I'm going to have 17, and if I attach my clock handle and I push down, positive rotation, so I have 17 kips, and it is 6 feet over. And then I've got plus 13 kips, it is 12 feet over. I've got this 65.6 straight through translation. I have the X component of BF straight through Y component. So the Y component is that 7.5, okay? It is plus 7.5 divided by 9.6, my hypotenuse, so that's the Y component, 7.5 over 9.6, times BF, okay, so that's my force, that's the Y component of this vector. It is also 12 feet over, and it is positive because as I'm pushing down, it's causing that positive rotation. This force straight through doesn't matter, so we are left with a pretty short equation right here. And we can directly solve for BF. When we do this, we can directly solve for BF. And if I did my math correctly, which you just never know with me, I'm going to get that BF equals negative 27.53 kips. And what does that mean? That means that BF is 27.53 kips. It's actually in compression. Okay, we don't say it's negative, we call it compression. Which means it's not actually pulling away, it's actually pushing up against, okay? And if I wanted to, I could have come down here and I could have drawn the same arrows anywhere I wanted to. But even if I was down here, I would have had to include the X component and the Y component as I came down. That's more math. I want to go where I've deleted everything, okay? So I now have AB and BF, and I know that BF is actually in compression, so I'm going to go ahead and kind of draw it in compression, and it's 27.53. The only unknown I have is GE, and I have lots of ways to get GE. I could sum forces X, okay? I could sum forces X. X component, X component, X component, get GE. I could sum forces Y. Y component of GE. I could sum moments about this point right here. Okay? If I sum moments about this point, I could break GE up into X and Y components. It's on this vector. So I know with this vector coming down, I'm going to have a Y component and an X component. Okay? And to me, that looks like a pretty good bet to sum moments right here around point B. Because if I sum it about point B, it gets rid of this top member, it gets rid of this diagonal member, it gets rid of an unknown, okay? And I'm going to break this vector into X and Y's. It's getting rid of that Y component, which leaves me the X. We get rid of this force that's going straight through, and we're back to just one force, solving for X. So I have negative 17 times 6 minus 15 times 12. This Y component is going through, okay, my X component is causing negative minus GF, but I need to go back and what was the X component? The X component was 6, the hypotenuse was 6.5, so 6 over 6.5 gets me that X component. And now, if I'm summing the moments about straight above it, it's not the entire 7.5, but it's 5. Okay, and all of this nonsense has to equal. And when I do this, if I do this correctly, I get 61.1 kips. And I know it's negative because they're all going in the same direction, which gives me 61.1 kips in compression. Okay, in compression. Now, there are 100 ways I could check my work. And if you're struggling with this, sum force is X. You've got all these known values now. Sum force is X. It should equal 0. Sum force is Y. Some moments about this point down here. Some moments about this point down here. You could play with the same truss. And you could write 6 more equations and make sure they came true. Okay? You know what the answers are. Write equations until you can get the consistently the right answers. Method of joints. Assume positive, so I have CD. I have DH, and I already know that this breaks down into 2.5 and 6. I have 15, and I have 8. And I want to know CD, so I'm going to highlight CD. Okay? It's an X component. I have an X force. DH also has an X component. So summing force is X, leaves me 2 unknowns. If I start with summing force is Y, okay, I can solve for DH, and then I can come back and solve for CD. So let's start with that. So here's a good point. Stop the video. Stop the video. Can you sum the forces correctly? I'm going to sum forces in the Y direction. Up is positive. I have minus 15 minus 2.5 over 6.5 DH equals 0. Okay, that's all I have in the Y direction. Y, and the Y component of this is 2.5 over hypotenuse DH. And I'm going to bring this over, and I'm going to get that DH equals, okay, DH equals, and it's going to equal a negative number, okay? So I have 2.5 enter 6.5 divided by, that's over here. I'm going to have to multiply by the reciprocal to get rid of it 15 times. And I get 39, negative 39 kips. So that tells me that DH is actually 39 kips in compression. You can either then call DH negative, or I like to just kind of go back and show it. So now when I sum forces in the X direction, to the right is positive. I have a negative 8 minus CD plus, because this is in compression, it's coming to the right, okay, plus 6 over 6.5 times 39 equals 0. And I find that CD is equal to, if I do my math correctly, 28 kips. It's positive, so it's in tension. Okay, so now that you know these members in this truss, you could do method of joints, work your way over, and make sure you got these values we got from method of sections. I mean, you really, to study for this test, if you can set this truss up and you can do method of, cut it here, do method of sections here, work your method of joints, you get the same answer. You could literally take the same truss from a homework problem or from lecture, and you could work it 3, 4, 5 different ways. Because it's an equilibrium, it doesn't matter how you set it up, you will get the same answers. And if you don't, you need to go back and check your free body diagrams and then check your math. Okay? So that would be an example of a truss.